Hey, Mrs. V here. So I'm going to go through our next set of notes, which is matter and chemical versus physical properties. And so if you haven't already, go ahead and go onto Classroom, find this matter and chemical v physical notes, and you're going to open up this Google Doc to take your notes. Like I said before, you can do it on a piece of paper, but you're going to need to transfer it to these Google Docs with highlights and summary and everything. Okay, so if you haven't done that, go ahead and get that ready, and we're going to start right now. Okay, so we're going to start talking about states of matter first, and then chemical versus physical changes from those states of matter. So we are going to have two essential questions in this PowerPoint. It does not mean I'm going to talk for an hour. It means that these are very condensed kind of ideas, and they kind of tie together. So our first essential question is, what are the states of matter and how do they behave? And then how do you identify a physical or chemical change? I wish you guys were in here. I actually have properties of matter and all kinds of posters up here in the classroom when you guys are going through this, which can help you understand. But you can look at this, and maybe I'll show you those on Zoom. Okay, so particle movement, that's a huge thing, but the biggest thing is there's three, count them, 1, 2, 3 states of matter. And particle movement just means how fast that they're moving around. So how fast is air moving around, or hydrogen, or oxygen, okay? And so there is a solid, which if you think about water, a single water molecule, when it's a solid, it's ice. And those molecules actually move very slow. So they move very slow. They're very cold. You can think when you're cold, you move very slow. Okay. And then you have a liquid, like with water. Okay. It's a medium movement. So those particles are kind of dance around. Okay. It's like when you're just kind of warm, right? And you feel okay. And then there's a gas. And gas is vapor for water. So when water becomes a vapor, it just disperses everywhere, and it just moves as fast as it can. And those molecules are just whoom, just like if it's hot outside, it's 110, you are moving as fast as you can to somewhere that's cooler. Okay. All right, we talk about kinetic theory of matter. And this, I just really want you guys to get the concept and the idea really down. But one of them is that matter is made up of particles which are in continual random motion. That means, such as vapor for water, those water molecules are out there moving however they want to move. There is no rhyme or reason to how they move. They just move. Okay, and they move at different speeds, they move different directions, they bounce off things. It's like they're just random and they just go all over. So that's what kinetic theory of matter pretty much tells us. Okay. The states of matter, the first one we're going to talk about is solids. So solids are tightly packed, and they're vibrating at a fixed position. So you see, this is like ice. They're still a little bit moving. Particles never really stop moving. They kind of move, but they move really slow and just a little bit. So almost like they vibrate. And it's a fixed position. Now, of course, if you put a cube of ice in your hand, it's not like it vibrates like your phone. You can't really feel it. It's very slow. It's very small. Okay? And so solid particles really have very little movement. Okay? And what happens when we add heat? So if we take ice and we add some heat, which really adds energy into it, we get a liquid. And it's like when we feed you, and maybe you wake up in the morning, you're more like a solid, and you kind of move really slow, kind of just waking up. At least that's what my daughter does. She's kind of like a solid, really, if I think about it. And once I feed her and get some food into her and some energy, she kind of more turns into a liquid. So she starts to move a little bit more. So particles of liquids are farther apart than in a solid and have higher volume than solids. So if you had a piece of ice and you put it on the table, okay, and you let it melt into a liquid, it's going to have a higher volume than it did when it was ice, okay, because the liquid takes up more space. Liquids have more particle movement than solids. So you can see in this picture, they're moving a little bit more. They're not moving as slow. So we've added some heat, or like my daughter, I gave her some food, and she starts to move a little bit more, a little bit faster, just a little bit. Okay, so what happens when we add heat to a liquid? It goes to a gas, okay? And so particle gas are very far apart, and they have the largest volume. So they go all over. You see, they're just bouncing all over the place. They are the most excited. I guess if you use my daughter as an example, this is when I give her caffeine or she drinks one of those Red Bulls. She's kind of like that. She just goes, okay? And gases have the highest movement in all states. So they move the fastest, and they have the largest volume, okay? What happens if we added heat to that? Some of you might ask. Well, nothing. It just becomes hotter. There's no other states for it to go to. All right, so let's look at physical versus chemical change. So physical change is a phase change. So you're going from a solid, liquid, or gas. So it could be ice melting. It's still water, but now it's a different phase. It was solid when it was ice, and now it's liquid as water. It is reversible. I can go from ice to water and water to ice, okay? Chemical changes are changes what it is. It's not reversible. So it's almost like when one of the examples is when you crack an egg and open it up, that's a physical change. You could technically put the egg back in the shell, but when you cook the egg, that is a chemical change. And that I can't take a fried egg or a cooked egg and turn it back into a raw egg. There's just no way I can do that, okay? And another example here is cooked pancakes. So once I cook my pancake, I can't turn it back into batter. It's just a pancake. So that's a chemical change. So here's some just kind of definition. So if you're watching this, I would pause this video right now because I'm going to go faster than you can probably write down. But this will just help you kind of give you a term to refer back to. So if we go from a solid to liquid, that's considered melting, and that volume increase and the density decreases. Okay? Remember, because they are inversely proportional. Liquid to solid, freezing, we call that freezing. And the volume decreases as the density increases, because remember, volume and density are inversely proportional. They are opposites. What if we go from liquid to gas? We call that vaporization, and that is a volume increase because gas has the largest volume, and the density decreases. Gas to liquid, that's what we call a condensation, and the volume decreases, the density increases. Solid to gas, that's something like dry ice. So if you have dry ice and you put it on a table, usually if you guys are here in class, I'm able to play with some dry ice with you guys. That's what we call sublimation, where it goes straight from a solid to a gas. And that is volume increases and density decreases. So make sure you get these into your notes, just kind of give you a reference point when we're talking about different things. All right, so how does physical and chemical changes affect properties? Well, if we do a physical change, it's going to change the volume. It does change the mass. Remember, the mass is about how much room it takes up. It doesn't change the weight. The weight will always stay the same, but the mass will change. It changes density, and same thing, stays the same thing, okay? Ice is still water. So in a physical change, it doesn't change what it is. It simply changes the phase that it's in, okay? Chemical changes, the mass changes because it turns to a completely different thing, so it might take up more space or less space. The density changes, the volume changes, and it is a completely different chemical thing. So you have to think about, and the biggest thing to think about between physical and chemical is, can I reverse it? Is there a way that I can actually reverse it? If the answer is no, I can't reverse it, then that's a chemical change, okay? All right, so now what I want you guys to do is go back in your notes. You're going to write your summary. Go back and process your notes. Highlight important information, underline vocabulary words or unknown words. Write down any connections you have with the notes in the left-hand column. You'll use all of that to write a 3 to 5 sentence summary using the processing you did above. And when completed, turn in completed notes to the Google Classroom assignment. So make sure once you finish that summary and have processed everything that you attach your notes to that Google assignment and turn it in. Your homework for us right now will be due next class, and it's the density and experimental air worksheet and the chemical/physical changes worksheet. And if you'd like me to go through some of those, just go ahead and access the other videos of these two worksheets so that you can get some examples done. Have any other questions? Get a hold of me through email or Remind. Have a great day.